treat acids. Acids are a very common end product in microbial fermentation. Some fermentation pathways will produce alcohols, and we may see some gases produce molecular hydrogen or CO2. So the question is, again, why would fermentation, let's say if we take fresh milk, and fresh milk, we take the pH is going to be around 7. Why would, and we'll actually describe the fermentation pathway, why would lactic acid fermentation by lactic acid bacteria help preserve the milk from spoiling in the absence of refrigeration? Okay, so we'll just tear this apart. Okay. Lactic acid bacteria are common components of the normal natural microbiota that lives on the surface of our skin and our mucous membranes. So in the old days when folks would milk dairy animals, and it could be milking cows or goats or buffalo or camel, any kind of mammal can be used as a producer of milk. The microorganisms on the udder, the mammary gland of that animal, have these good, we're going to call them good lactic acid bacteria. So in the process of milking, the lactic acid bacteria were transferred into the milk. Now what those lactic acid bacteria would do, if the milk was left at normal environmental temperature, the lactic acid bacteria would start using the milk sugars, the lactose for example, and use it as a carbon and energy source, and they would ferment it. And a specific pathway that they use is called the lactic acid fermentation pathway. Now the milk sugar, the lactose, will be converted into lactic acid, and hence, the name lactic acid fermentation pathway. How would the taste of the fermented milk? Yeah, good. Compare, how would the taste of the fermented milk taste compared to fresh milk? It's going to taste, wow, sour. Okay. Now we detect high hydrogen ion concentration. We detect acids by the sensation of something being sour. So we'd say the milk is sour, but not in a bad way. It's not spoiled. So we want to recognize that by the bacteria carrying out lactic acid fermentation, converting lactose into lactic acid, what happens to the hydrogen ion concentration of the fermented milk? It goes in, yeah, it increases, right? And thus the pH does what? No. It decreases, right? And what did we just learn today about acids and protein denaturation? Will acids cause denaturation? Yeah, right. Good. Okay. So through fermentation of milk, we drop the pH. Okay, we make it acidic, and that acidic environment can inhibit the growth of spoilage microbes. Inhibit means what? What does inhibit mean? To stop, right? To stop something. The acidic environment inhibits growth of spoilage microbes. And what do we mean by spoilage? Well, usually, like, I simplify spoilage by proteins being torn apart. And we often end up with really horrible end products, like cadaverin, like from cadavers, putrescin, the putrefying smell of a rotting corpse. Lovely, lovely, right? You don't want to drink milk that smells like that. Okay, so this acidic environment through protein denaturation is going to inhibit the growth of spoilage microbes. Okay, so the acidic environment inhibits growth of spoilage microbes. And as a consequence then, we can preserve the nutritive value of the milk in the absence of refrigeration. Now, what are some of these fermented milk products? Yeah, classic one is cheese, right? Another one is yogurt. There's many other ones. Kefir is another fermented milk product. Okay, so if we were to compare the pH, okay, so fresh milk, we said pH is around 7. Okay, we took the pH of, we tried to make a solution of cheese, and we came up with a pH of the cheese we tried of around 6. Okay, and this is the one I really want to focus on, you guys, the yogurt. Okay, we ended up with a final pH of our yogurt around 4. Okay. Now, I want you to understand this concept of how fermentation with acid production preserves the food, but then on the lab practical, I'm going to ask a more specific question. Okay, and for that, on the lab practical, question really similar to this one. Okay, so let's say we've got our fresh milk pH 7, and we're going to compare it to fermented milk, the yogurt, pH equal to 4. Okay, now this is how the question usually will be worded. So first of all, which of these substances is more acidic, the yogurt or the milk?
Yogurt.
Right? The lower the pH,
The acidic.
the more acidic, the higher the hydrogen ion concentration. So this is more acidic. Okay, and now the next question would be, okay, how many more hydrogen ions does the more acidic substance have compared to the less? And this is tricky, you guys. This is a tough one. This really messes with folks. So what we want to remember, the thing we forget, remember the pH scale. The pH scale is a log scale. It's a log scale. That means each pH unit is a 10-fold difference in hydrogen ion concentration. Okay, so here's the trick. When I ask you those questions, comparing the more acidic substance to the less acidic one, how many more hydrogen ions does the more acidic substance have? Always put base 10. Just right off the bat, put base 10, right? Now all you need to do is fill in the exponent. And how will you determine what the exponent will be? It's just a difference in the pH units, right? So 7 minus 4 is what? 3. So this means the yogurt has 1,000 times more, 10 to the 3 times more hydrogen ions than the milk. You will see that question for sure, so make sure you feel okay with how to answer it. Do another quick one, you guys. So what if you're comparing milk to the cheese? Okay, and the milk again, pH 7. The cheese, the example we gave was pH 6, right? Which is more acidic? Cheese, okay? And how many more hydrogen ions does the more acidic substance have than the less? What do we put what? We put base 10, right? And what's our exponent? 1, right. 7 minus 6 is 1. So the cheese has how many more hydrogen ions than the milk? 10 times more, right? Okay. You just make sure you guys can do those. They aren't hard once you have a strategy, right? All righty. Okay. So one other example that's in your lab manual is if you look at lactic acid fermentation of vegetables, like cucumbers, okay? And you can pickle all kinds of veggies, but we'll just use cucumbers, say fresh cucumbers. Following lactic acid fermentation, you can make pickled cucumbers, right? And they're sour, right? Pickles. Okay. And when we ran this using pH strips, the cucumbers had a pH around 7, and our pickles came up with a pH around 3. Yeah. So which is more acidic?
Pickles.
The pickles, right? The pickles. And what's the difference in hydrogen ion concentration? The pickles have how many times more hydrogen ions than the cucumbers?
4.
So is it 4?
10 to
there you go, you guys. Don't let that get you, right?
times.
So the pickles had 10 to the 4th times more hydrogen ions, or 10,000 times more hydrogen ions. Wow, that is really going to inhibit those spoilage microbes, right? Okay, good. Now that's a big one, you guys. So we'll put stars by it. Really important to know for the lab practical. Okay, all right. Now we'll go over to our class results, you guys. And I don't want you to stress too much. And the reason,